Welcome to Ask and Learn.
Hello students, in this question, a wire is turned to form a triangular loop of base B is equal to 38 centimeter and its height is 60 centimeter and the resistance of the wire is 2.5 ohm, and we are asked to calculate the first subdivision is angular frequency of the rotation. It is rotating at certain frequency and we are asked to calculate the angular frequency omega. We know that omega is equal to 2 pi by t and it is given that time t, the period t is equal to 1.6 second. Therefore, 2 into 3.14 divided by 1.6, which will be on calculating we will be getting omega is equal to 3.925 radian per second. Next, we have to calculate the maximum current, maximum induced current, that is maximum induced current. This can be calculated as I max is equal to B into A into H divided by rho, and A is the area of the triangular loop, B is the magnetic field of 1 Tesla and H is the height, rho is the resistance. Here we are going to take the resistance alone. Therefore, area is equal to half into base into height. On calculating this, we will be getting 0.114 meter square. While substituting this, we will be getting 1 Tesla into 0.114 meter square into 0.60 meter divided by 2.5. So on calculating this, we will be getting the I max is equal to 0.0274 ampere. Next, we have to calculate the magnetic flux through a loop. Magnetic flux through the given loop. So we know that the formula phi is equal to BA cos theta. So at time t equal to 0, the base of the triangle is along the x-axis, whereas its height is along the y-axis. But at time t equal to 0.6 second, the wire has rotated through a angle which is given by theta is equal to 360 divided by t into t. That is equal to 360 divided by, we know that the period is 1.6 and time is at time t equal to 0, the base of the triangle is along the x-axis and the height of the triangle is along the y-axis. At time t is equal to 0.6 second, it rotates through the angle. Therefore, in place of time t, we are substituting 0.6. On calculating this, we will be getting theta is equal to 135 degree. So now phi 1, let this be theta 1. Theta 1 is equal to 135 degrees centigrade. Now phi 1 is equal to BA into cos theta 1. B is 1 Tesla and the area is 0.114 meter square and cos theta is cos 135. On calculating this, we will be getting phi 1 is equal to minus 0.0806 kilogauss per meter square. Now next we have to calculate the induced current in the loop. That is, induced current in the loop can be obtained by using Faraday's law of electromagnetic induction. Therefore, this is given by E is equal to minus d phi by dt. To find I, d phi by dt at time t is equal to 0.6 seconds. Therefore, d theta by dt. For this we have to calculate d theta by dt is required. So it is equal to 360 divided 1 by 6 is equal to 225 degree. Then also we know that theta 1 is equal to 135 degree. Therefore, we will be taking d theta by dt is equal to 225 degree per second. That is d theta by dt at t is equal to t1 is equal to d theta by dt at t is equal to 0. Both are equal to 225 degree per second. Then we will be calculating. Now d phi by dt has to be calculated. At time t is equal to t1 is equal to b differentiation of ba cos theta divided by dt. On differentiating we will be getting minus ba into sine theta. Therefore, b is 1 Tesla into area is 0.114 meter square into sine of 130. Sorry, this is 225 degree per second, which is equal to minus. Therefore, on calculating this, we will be getting 3.83 into kilogauss per meter square. Then the electromagnetic induction E has to be calculated. So induced current in the loop is obtained by this equation. Hope you find this video useful. Thank you.